Okay, so today in class we did a Pogil about Q. And so the first part of the Pogil asked us to confirm that the equation was actually at, the reaction, was at equilibrium. So we just substituted into the K. Remember, K is the products, the concentration of products over reactants raised to the powers. And we saw that K is equal to 1 times 10 to the third, or 1,000. And then it told us that we've actually shifted it told us that we were going to add some reactant. And when we did that, we calculated a new ratio, which is called Q. And that was products over reactants. Now, some of you might still be confused looking at this because they look exactly the same. The only difference, and this one's also raised to the powers, right? The only difference here is that one has a letter Q and one has a letter K. So you might wonder, how do we tell them apart and why do we need them? The difference between the two is that K is only calculated when a system is at equilibrium. That is the ratio that must occur for the system to be at equilibrium. Q can be calculated at any point. So before the reaction starts, or in this case in the middle of the reaction when we added some reactants, we injected it with the needle. So when we calculated the Q, we found 4.55 times 10 to the second, which is 455, which is way smaller than the K. And so by looking at these two numbers, what you should see is that in order for the system to shift to reestablish the equilibrium, this top number would need to be bigger because we increased the bottom number and that caused the ratio to become smaller. So we'd have to shift and adjust by making more of the top. Okay, so when we talk about Le Chatelier's and how it might shift, what we're actually talking about mathematically would be that the top number would have to change in the ratio. So why do we use Q is basically the point of this Pogil. Q helps us look at the ratio so that we can compare at any point in a reaction what would need to happen for it to establish equilibrium. When Q equals K, we're at equilibrium. When Q is less than K, like in this case, we need more products. And if Q were to be greater than K, we need more reactants. Okay, so what I'm going to do is actually show you how we can calculate this change. So this is what we're going to be doing in class on Friday, and that is, we're calling them ICE problems because you have an initial, a change, and then the equilibrium. So I'm going to show you that in a separate podcast. So this is the end of the Q. So go ahead and when you're ready, watch the ICE one so that you're ready for class on Friday. Okay, thanks.